Hello guys, welcome to another episode of Set Theory. So I just did the part 1 and I'll put the link in the description. So the part 1 was all about sets and representation of sets. And I solved the first exercise of the Ncert textbook of 11th standard. I'll put the link in the description. You can go and download it for free. So in this video, we're going to be discussing about empty sets, finite, infinite sets, equal sets, and we'll be solving exercise 1.2. So without wasting any time, let's get started. So what is empty set? So empty set is the one which has no elements in it. So empty set is basically empty. Empty set is the one which doesn't has any element inside the set. So empty set is denoted by phi. So this is how empty set is denoted, or you can simply write two flower brackets with no elements in it. So this is how we denote empty set, either by using this sign. It's called phi. It's a Greek letter, or by simply writing this two empty flower brackets. So that was the first one. And the next one is finite set. So it's basically from the name itself you can understand the definition. Finite set is the one which has finite amount of elements in it. So finite set is the one which has finite elements or countable elements. So infinite set is the one which has infinite amount of elements. That's it. If the number of elements here is uncountable or infinite, is an infinite set. Is the number of elements in the set is countable, it is a finite set. So that's basically the difference between these two. So for example, for an infinite set, I can say a set of all natural numbers. So all natural numbers, say they start from 1, 2, 3, 4, so on. The number of elements here is up to infinity, so you can't count. So you can categorize this as an infinite set. So for the example of finite set, I can say the set of first 10 multiples of 3. So that is a finite set. First 10 multiples of 3 is 3, 6, 9, 12, 15, so on up to 30. So here you have finite number of elements, so I can categorize this as a finite set. Whereas here we have infinite number of elements, so that's why we categorize that as infinite set. Now one more thing which you need to know is equal set. Equal set is basically if one set, the elements in one set as exactly equal in the other, you can call that as two equal sets. So for example, so basically equal sets, if elements of set A is exactly matching with the elements of set B. Elements of set B. For example, if I have my set as say 1, 2, 3, 4, and if I have second set as 4, 2, 3, 1. As I told you, order in a set doesn't matter. So I can see 1 is there here, yes, 2 is there, yes, 3 is there, yes, 4 is there, yes. So if every single element of one set is there in the other set, you can call those two sets are equal. So these two sets are equal only if every single element of A is equal to every single element of B. So this was the basic introduction of the second part. So now let us start solve the exercise 1.2. So here's the first second exercise. So this exercise 1.2. If you have textbook, please keep the textbook. If you don't, it's still fine. I'll write all the questions with the answers. So just hang out with me. So we're supposed to find the null sets in these 4 questions. So the first one is set of all odd numbers divisible by 2. So what are all odd numbers? It's in the form of 2n plus 1. Now is this divisible by 2? Let us find this. So 2n by 2 plus half, you're gonna get as n plus 0.5. Now this is not a integer. Now I can say from this, not all odd numbers, not even like every odd number is not divisible by 2. Just take any example if you want. You can either do by this, like every odd number is represented by this formula 2n plus 1, and they're saying it is divisible by 2. So I divided it by 2, and then I've split it, and I've got this. So this is not a whole number. So from this I can say set of this is an empty set. Or else another way of saying this is you can just take some random odd numbers. Let's say I'll take 1, 3, 5, 7. So you just take any numbers from this sequence and just try to divide it with 2. You're not gonna get your answer as a whole number. So for example, 1 by 2, you're gonna get 0.5. 3 by 2, 1.5. So you don't get whole numbers. So from this I can say set of all odd numbers is divisible by 2 is 5, which means it is a null set or empty set. So this is an empty set. And the next one is set of all even prime numbers. So the only you might be knowing this, the only even prime numbers in the number system is 2. 2 is the only even prime number, so this is a singleton set or a set with single element. So this set I can write 2, which means this has element in it, so this is not a empty set, not empty set. So third one is set of all x such that x is a natural number. X is a natural number where x is less than 5 and x is greater than 7. So if you have this kind of equation in equation problems, so just try to write in the form of number line. Always try to write in the form of number line. So they're saying, so start with 0, -1, -2, 1, 2, 3, 4, 5, 6. They have given till 7, so I'm going to extend till 7. 6, 7, 8. Now they're saying x is greater than 7 but not equal to 7, so I just need to circle this. If you don't know how to do this, check my first part of this set theory. I'll put the link in the description. So let's start. So let's continue. So x is greater than 7, which means all the numbers towards the right, and x is less than 5. So less than 5, not equal to 5, so don't need to circle this. So towards the left, and you can see there is no intersection between these two lines. So if there are any intersection, which means they have common points, which means there are elements in this set. Now from this I just saw there is no common points here in these two lines, which means there are no elements in this set, so I can say this is an empty set. So this is 5. And the next one is set of all y such that y is a point common to any two parallel lines. So if you take any parallel lines in the Cartesian system, so take any parallel lines. Parallel lines, the basic definition of parallel lines is the lines which does not cross each other. And they're saying y is a point which is common to two parallel lines, which is impossible. So from this I can say this is also an empty set. So this is how we basically solve this kind of problem. So now let us solve the second main. So the second main is we are supposed to categorize this as finite and infinite sets. So let's start with the first one, the set of all months in a year. So this is every month has finite number of, every year has finite number of months. So this I can say it is a finite set. Finite set. Here the next one is 1, 2, 3. It's so if this write this 3 dot, which means it keeps on going with the same pattern. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's this set of all natural numbers. So this is, of course, it is infinite. It is an infinite set. Now the third one is 1, 2, 3, 4, and then so on till 100. Set of all natural numbers from 1 to 100. It's basically finite set, so easy. So this is a finite set. So the fourth one is, so if you know how to solve this, so please pause and try to solve, and then play and check with my answers. So you can try that. So the fourth one is set of all positive integers. So this is positive integers greater than 100. So use the number line method. So they're saying greater than 100, which means x is greater than 100. So basically 0, 1, 2, 3, all the way up to 100. So they're saying all the numbers greater than 100 starts from 100, then goes till the infinity. So from this I can say there are infinite amount of elements here. So I can say this is an infinite set. Either you can use these kind of number lines, represent this in a mathematical way and use this number lines, or you can just use simple logic to solve this. Now the best way of solving this, of course, by using these kind of mathematical representation, because if you use maths, you're never gonna be wrong. So I suggest you to solve using this kind of thing, but if you use logic, it's still fine. How do you solve using logic? Greater than 100. So how many integers are there? Infinite number of integers. So positive integers greater than 100 means it starts from 101, 102, 103, 104. It keeps on going. So how many elements are there? Infinite amount of elements. So infinite set. And the last one is set of all prime numbers less than 99. You must keep a note that prime numbers are always natural numbers. So they're saying there are less than 99, which means, as you know, prime number starts with 2, 3, 5, 7, all the way goes up to, I think, 97 is a prime number. So this, or all these numbers are, there are finite number of elements in this set. So from this I can say this is a finite set. So it's quite easy to solve. Just try to understand the problem more. So let us try to solve the third main now. So the third main is also basically finite and infinite. We're supposed to find which set is finite and which set is infinite. So the first one is set of all lines parallel to x-axis. So this is y-axis, if you know Cartesian plane properly, and this is x-axis. So how many parallel lines can I draw which is parallel to x-axis? Infinite. I can draw this. I can draw so many parallel lines which is parallel to x-axis. So this is an infinite set. Infinite. And the next one is set of all letters in the English alphabet. Of course, It is finite set. It starts from A and ends with Z, and so it's a finite set. And the third one is set of all numbers which are multiples of 5. So what are the multiples of 5? Now you just need to either you can use, as I told you, can use logic or you can use math. So you'll solve using logic. Set of all numbers which are multiples of 5. So multiples of 5, 5 ones are 5, 5 twos are 10, 15. It keeps going. So 5, 10, 15, 20, 25, 30. How many numbers are there? There are infinite number of elements which I can write here. So it keeps on going. So I can say this is an infinite set. And the next one is set of all animals living on Earth. So it's obvious there are infinite number of animals on the Earth presently. So I can write this as a finite set. And the last one is set of all circles passing through the origin. So this is the origin. So how many circles can I pass through this origin? Infinite. So this is one circle. This is one more circle. One more circle. One more circle. In this way also I can draw 1, 2, 3. I can go in this way also. 1, 2, 3. I can go in downwards also. 1, 2, 3. I can keep going from all the directions. So how many circles I can draw? Infinite. So this is also an infinite set. So I hope you guys are noting it down or trying to understand this. So this is the fourth main. We have to check whether A is equal to B or not. So equal sets, as I told you, is the one in which every single element should be there in the other set. So it's basically exact copy paste, but even if the elements are shuffled, no problem. But the element should be there. So let us try to solve the first one. So first one is A equal to A, B, C, D, whereas B equal to D, C, B, A. Here you can see it's kind of shuffled, but let us see whether every element is there or not. So A is there, yes. B is there, yes. C is there, yes. D is there, yes. So I can say A is equal to B. So the next one is 4, 8, 12, 6. So let us say 4 is there, yes. 8 is there, yes. 12 is there, no. 16 is there, yes. But 18 here and 12, they are misplaced. So these two elements are totally different. So I can say A is not equal to B. A is not equal to B. So now let us try to solve the third one. So A equal to 2, 4, 6, 8, 10, whereas B equal to set of all x such that x is positive even integer and x is less than or equal to 10. So if you have inequalities like this, just use the number line. They're saying x is less than or equal to 10. So we'll only basically include all the positive ones. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they're saying equal to 10, less than or equal to 10. So I need to include 10 also. So as I told you, if you shade this circle, which means you have to include that, because they're saying equal. If it suppose if it is like this, I would have drawn like this, which means I should not include that number. So here, since equal to is there in the question, I should include that the boundary number also. So less than or equal to 10, which means all these numbers. So they're saying positive even integer. So even integers are 2, 4, 6, 8, 10. So you should include 10. Remember that. So elements are 2, 4, 6, 8, 10. Now is this matching with this? Yes, 2, 4, 6, 8, 10. So I can say A is equal to B. So this is how you can solve this in a nice elaborate way, but a easy way. So the fourth one is A is equal to set of all x such that x is multiple of 10. So what are all the multiples of 10? So they're not saying any boundary, so I can take anything. So minus infinity all the way up to minus 30, minus 20, minus 10, 0, 10, 20, 30, keeps on going till infinity. So there are many numbers here. It's an infinite set. So these are all the multiples of 10. And here they're saying b equal to 10, 15, 20, 25, 30. Of course, they both are not equal. So from this I can say A is not equal to B. So now let us try to solve the fifth main. It's basically the same. We'll have to check whether A equal to B or not. So the first one is, so A equal to 2, 3, whereas B equal to set of all x such that x is the solution of this quadratic equation, which is x square plus 5x plus 6 equal to 0. Now as you know, there are many methods to solve quadratic equations. So I'm going to use a factorization method to solve this. So we have the equation x square plus 5x plus 6 equal to 0. So we need to refine the factors for this. So basically you have to take this number. So it's like this, ax square plus bx plus c equal to 0. So I have to take c and to take b here, and you have to find two numbers such that if you multiply these two numbers, you should get C. Whereas if you add, so if you add these two numbers, you should get this. Whereas if you multiply, you should get C. So you have to find those two numbers. So here C is equal to 6, whereas B equal to 5. So I have to find two numbers. What are those two numbers? If I add them, I should get 5, and if I multiply them, I should get 6. So basically it's 3 2. If I multiply 3 2, 3 2s are 6, whereas if I add these two, I'll get 5. So I found the factors. So that's how it's done, factorization. And then you have to take those numbers and write in this way. This is basically plus 3, right? Plus 3 and plus 2. So x plus 3, x plus 2 equal to 0, and then x equal to, so then you have to write the two different equations. So x plus 3 equal to 0, x plus 2 equal to 0, x equal to minus 3, x equal to minus 2. So what are the solutions of this B? So B in the form of Rooster form, I can write like this: minus 3 comma minus 2. Are these two equal? Absolutely not. So A is not equal to B. So A is not equal to B. So the solution is this factorization. You can find this. What normally people think is they just imagine these two are the solutions and then they write B equal to 3 comma 2. No, these are not the solutions. You have to find the solutions by multiplying like this and then taking the two equations separately and then finding the answers in this way. So you have to keep that in mind. So that's the thing from the first problem. The next one is A equal to set of all the. I suggest you guys to solve this. It's very easy, but I'm gonna write the solution anyway. So pause the video and try to solve this. So A equal to set of all x such that x is a word, x is the letter of the word follow, whereas set of B set of all y, whereas y is the set of all the letter of the word wolf. So A answer is going to be FOLW, whereas B answer is going to be WOLF. Now we have to check whether they're equating or not. Yes, F is there, yes, O is there, L is there, W is there. So I can say A is equal to B. Easy, simple. So this is how we solve these kind of problems. There is one last problem. I'm going to solve that one. So the last problem of this exercise is, so we have to select the equal sets. So we have A equal to 4, 2, 4, 8, 12. So we have to check whether anything is matching here. So 2, 4, 8, 12. No. 2, 4, no. No. No, no. So A is not equal to anything. So I can just remove this. Now B, 1, 2, 3, 4. Whether whether it can match with anything. So 1, 2, 3, 4. No, 1, 2, 3, 4 is not there. Yes, here it is there. 1, 2, 3, 4. So I can say B is equal to D. So this is gone. These two are gone now. Now next, C, 4, 8, 12, 4, 8, 12, 14. Of course, nothing is matching. So I can cancel this also. The next one is E equal to minus 1 and 1. Anything is matching? Yes, these two are matching. So E equal to G. So I'll remove these two now. The next one is F equal to 0 comma A and H equal to 0 comma 1. No, they're not matching, so I can remove these. So only two equal sets in this problem is P equal to D and E equal to G. That's it. So this was the end of the video. If you learned something new, please consider subscribing the YouTube channel, and for the upcoming videos, please hit that notification bar, and I meet you in the next video. Thank you.